done and share my screen. Start the broadcast. Let's see, testing. Yes, okay, I can see that that'll work for me. All right, so we'll start here. Okay, that 10% mic. Oh, go with this. Okay, let me see. So, welcome scholars. Let's see. So, I'll be updating grades again. My goal is to get the grades updated by Monday. Yeah, so we're just going to kind of continue on. So I think on this past Monday, we kind of went through a library of functions. So today we'll go through. Oh, good, they won. Okay, we'll go through as many of the corresponding homework assignments together as we can. If you have questions, feel free to either unmute yourself, type your question in the chat, or put it in the Q&A, and I will make sure to get it addressed. This is right. Don't connect audio and join. Okay. And so we're gonna let's hop over to my math lab and okay. Let's generate. We'll start with question number 11. Okay. Stay as a participant. Let me see if that makes it any better or worse. Reclaim as host. Let's see if that's any better. Testing. Okay, I can see my screen and I can see my audio. Okay, I think we're okay. So we're gonna wrap that for now. Okay. Zoom in just a little bit. The zoom on this is a little bit tricky. We'll let that be. All right, so this question comes from section 1.4, question 37. Using the graph of the given function, find the following. Are there any intercepts? Okay, so our x-intercept. So where it crosses the x-axis, looks like it's plus or minus 2. Okay, let's just put negative 2 and 2. Y-intercept looks like it's a positive 2. The domain. So in a graphical sense, the domain is the very left to the very right. If we took this image and smushed it onto the x-axis, what x values would it touch? So the very left looks like it's negative 3. The very right is positive 3. And we're going to use square brackets because we actually touch or include those endpoints. So we're going to say from negative 3 to 3. Okay, so that's the very left to the very right. The range is going to be the very bottom to the very top. So if we took this image and smushed it onto the y-axis, what y values would it touch? So the very bottom looks like 0, the very top is 3. And square brackets again because we actually include those endpoints. Okay. Okay, increasing, decreasing, and constant. So increasing, right? As we trace the graph left to right, initially it's decreasing. And then it's increasing as x goes from negative 2 to 0. And then it's decreasing again. And then it's increasing again as x goes from 2 to 3. Okay. So it's increasing. Interval notation. So again, I'm under the impression that whenever we're doing increasing, decreasing, or constant, we should use parentheses. And we're saying that the function is increasing as x goes from negative 2 to 0. Okay. And then it's increasing again as x goes from 2 to 3. That was it? No, continue. Over which intervals is the graph decreasing? So that's okay. It's decreasing as x goes from, what is that, negative 3 to negative 2? Then again, as x goes from 0 to 2. Okay. Continue. And then constant, the constant is the graph is not constant on any interval. It never flattens out. Any kind of symmetry, right? Even, odd, or neither. All right. Do we have y-axis symmetry? It looks like we do. All right. Yeah. It looks so. If we have y-axis symmetry, is that even, odd, or neither? That should be even. Let's see. 1, 2, 3. Yeah. Yeah. Every time I check all the points, they seem to be symmetric about the y-axis. Okay. All right. That was a pretty interesting question. Kind of a lot of parts to it. Let's look at question 7. 11, 10, 9, 8, 7. Why was 10 afraid of 7? Because 7, 8, 9. Determine algebraically whether the given function is even, odd, or neither. Okay, algebraically. So let's take some notes on this guy. Let's take some notes here. Okay. And while we take notes, I will go ahead and open up a poll. Oh no, that's not what I wanted. We can work with it though. No, that's not where the poll is. Here, hold quizzes. We want this one. Okay. So there is an active poll. We're going to let A be the first choice, B be the second choice, and C be the third choice. And so while you ponder and you submit your results, we'll do a showcase on how to answer this algebraically. So let me start by getting a copy of the question. I think we got some activity. All right, guys. That's kind of irking me. Delete. How can we get rid of that? Oh, show close. Did it give us another question? No. No. See, that's what I didn't want. I'm going to refresh this. And now can I get rid of that thing? Let's see. What was the question that we had? Well, we're on 6. We were on 7. Okay, let's see if we can get this to work. So let me restart the poll because it may have changed things around. So I'm just gonna relaunch it because it may be a different question. Yeah, that's fine. Okay. All right. So let me get a copy of this guy. Dog, like, what is she doing? She's like at the top of the stairs trying to sniff under the door. So she sounds like some monster trying to get in. It's so creepy. It's like this heavy, I'm like, it's distracting and it's creepy, but it's funny. So anyway, let me see. Okay. Oh, so I was trying to avoid. We'll get it. We'll get it. All right. So then it's here. All right. All right, let me grab my pen. Okay, so let's see how to show algebraically whether a function is even, odd, or neither. So this is like a test to show symmetry. Again, if it's even, that means we're going to have y-axis symmetry. If it's odd, that means we're going to have origin symmetry. If it's neither, then there's neither of those types of symmetry. Okay. So the way we go about this, we replace each x with negative x, and then we simplify and analyze our result, right? Okay. So first I'm going to replace each x with a blank set of parentheses. Okay. And then 2x squared minus 9. Okay. And then into each blank parenthesis, we're going to put negative x. Okay. Next, we want to simplify. So we have an even number of negatives, or a negative number raised to an even power. So that final result should be positive. Okay. And then notice that this is the original, right? So we have g of negative x equals g of x. That's the definition that we have for a function being. I want to submit my results. So unfortunately, I do have to show it over here because of where I have it, but that's okay. I'm going to go like this, submit, and I'm going to end the poll. Okay, we got some. I like the data. I can see our data. Now, see, that's one thing. I guess maybe I'll switch it back because I would like for you all to see the data. So I think I will switch it back. Let me go ahead and do that now. I'll do it after this question. Right, but this should be even. Okay. So that's the definition of a function being even. When we evaluate g of negative x, it takes us back to the original. That's the definition of a function being even. Okay, so we're going to go with even for that one. Okay, and final check. Okay. So before we go forward, let me switch this around. This one. Nope. Let's try that again. This one. Oh, okay, that's fine. Close. All right, we'll work with that. Okay. And let's run our number generator. Let's go to question 18. 3210 1918. Nice. Okay. All right. Find and simplify the difference quotient of this form. Okay. Do we need to take notes? All right. I'm going to try my hand at taking notes here. So basically, we're finding the slope between 2 points. Nope. No, I think I need to write this one down. I was going to do it here, but when I'm looking at it now, we need to write it down. I thought we could be a little bit concise, but we definitely. So let me start by getting a copy. Hopefully I can get this thing to work. It's been kind of giving me a little bit of a hard time, but that's okay. All right, so I think if I hit this, okay, come on. That. And we want to take that. There we go. We can work that. All right, and let's expand. All right. So this question comes from section 1.4, and it's question 57 from the back of that section. So we're going to plug in what's given, right? We have this difference quotient on the right-hand side, this model, and they give us that a is equal to 3, right? So what we're going to do, we're going to say f of x minus f of 3 over x minus 3, right? We're going to simplify this to see if anything happens. So f of x is going to be 5x squared plus x minus f of 3 is going to be 9 times 5 is 45 plus 3, okay? I think that's okay. And then still divided by x minus 3. Let's keep going. What is that, a 48? Ooh. Let me see, 9 times 5 is 45. Yeah, 48. Okay. So at this point, we have 5x squared plus x minus 48 over x minus 3. All right. So I kind of grimaced a little bit because, I was anticipating we need to factor, right? And the challenge is that leading coefficient is not a 1, right? So we need to try our factoring technique. So I'm going to use this technique I call it the AC method of factoring, where I'm going to multiply the 5 times the 48, and then I'm going to get a result. And I'm going to be looking for two numbers that multiply to give me that answer and add to give me 1 from the middle term, right? Let me see, 5 times 4 is 20. So that's 240. That makes sense, 240. Okay. So off to the side, looking for two numbers that multiply to give me 240, right? Now let me write out the factors of 240. I think we did 5 times 48, but it's also, we can do 24 times 10. Let me just check something real quick. Hey, Google, what's 5 times 48?
5 times 48 that should be 240.
Right. All right, okay. So 24 times 10, right? 24 is what, 8 and 3? Okay. So 8 is 2 times 2 times 2. And then another 2 from the 10. We got the 3 from the 28 and the 5 from the 10, right? So again, we said 240 was 24 times 10. All right, or you could do your factor tree off to the side. Eventually, you'll get to this point. So now we're going to go through all combinations and stop at the line that adds up to 1. All right, this is just how I do factor my trinomials, right? You don't necessarily have to do it this way. All right, so then 1 and 240, but that does not add up to 1, so we're going to keep going. So now check this out. So if we use a 2, right? What's left over? 120, yeah, left over, but those are not the two numbers we're looking for. Can we do 1, 2, 3? You know. So if we use this 3, what's left over? 16 times 5 is 50 plus 30 is 80. These add up to like 77, so we're going to keep going. Can we do 4? Yeah, there's a 4. 4 is right here. Okay, if we use that 4 already, what's left over? 10 times 6 is 60. Yeah, that makes sense. I'm going to just keep going. Can we do 5? Yeah, we can do 5, right? Because if we use this 5 right here, what's left over? 16 times 3 is 80 plus 16 times 3. We're getting close. Let's just keep going, right? I'm going to continue kind of over here, though. We can do 6 right here. So then what's left? A 10 and a 4 is a 40. We're almost there. Okay. We can't do 7. There's no 7 in those factors. Is there an 8? There is an 8. So if we use this 8 here, what's left over? 10 and 3 is 30. Okay. Can we do 9? There's no 9. We can do 10. If we do 10, that gets rid of this guy along with this guy. 8 and 3 is 24. Okay. We can't do 11. We can do 12. If we do 12, that's going to be what? 4 and 3. So this is gone. And it looks like we got 20 left over. 12, 13, 14. I think we can do 15. All right. If we do 15, I think those are the two numbers. We finally got there, right? 15 and 16. Let me see. We want the two numbers to add up to a positive 1. So these are the two numbers that we were looking for, right? So now we're ready to factor. So now I'm going to use this thing called the box method. I think I got it from some students in the past. Let's do this color. All right. So with the box method, the upper left-hand corner goes our leading term. Bottom right is our constant term, which is this guy. And then on the off diagonal, we want to use the two numbers that we just found. Okay, I'm going to do negative 15 here and a positive 16 here. Okay, you could do the other that those two can switch places and it'll be fine. Okay, so then to bring it on home, like for instance, if we compare the two on the top, what can we factor out of the two on the top? What's their greatest common factor? All right, we got 5x squared and negative 15. The greatest common factor looks like it's a 5. Now let me think about this. Oh, sorry. I'm missing something. So I am missing, I'll put it in orange. There needs to be an X here and an X here. All right. That's better. Okay. So we can factor out a 5x from the 2 on top. Okay. So if we look at the 2 on the bottom, I know they're both at least divisible by 8. So does 16 go evenly? Is that a 3? 30 and 18? Yeah. So we can factor out a 16 from both of those guys. And it's like it's a positive 16. Okay. If we compare the 2 on the left, what's the greatest common factor? It looks like it's just an X. All right. Okay. And the 2 on the right, what's the greatest common factor? Is it a -3? Because there'll be a 5 left there. 1 and 16. Yeah. So it looks like it's a -3 is the greatest common factor there. All right. So then our claim is that I'm just going to kind of actually, I wanted to come to about here. So our claim is that numerator factors into 5x plus 16, okay, times x minus 3, right? So that's factoring. That's something that we expect you to know beforehand. This is why I don't think you all have a lab, but you know, there is some practice. If anybody wants more practice on factoring, if you go, like, if you're going to access, you know how we access our notes, like from Blackboard, there's the folder that says box link. Inside that link that says box link, instead of clicking on the notes folder, you're going to see a folder that says handouts. That handouts has like a little synopsis on factoring. So basically every scenario that you'll come across in our course, essentially, I would say at least 90% of them you'll find in that chapter. There might be a few surprises, but it'll be minimal, right? So the technique that you saw me do here, it's a combination. First, you saw me do the AC method where I said the A times the C, the 5 times the 48, that gave us the -240. I know it was a large number, but that's how it goes at sometimes. So you just have to kind of roll with the punches. Because this leading coefficient was not a 1, that's what kind of made it a little challenging, right? So then we had to find, we went through all the factors of 240, and we stopped at the line that added up to a +1. All right. So we found those 2 numbers. So then once we had our 2 numbers, then we went over here to this burgundy and we did I call that the box method for factoring a trinomial, right? So you have tons of videos on YouTube with that. The leading term in an upper left, the constant term is the lower right. And we kind of made a mistake. We had to go back and add our x's, but we rewrote that 1 using those 2 numbers that we found, right? And then we just compared. What do these 2 have in common? This guy to the right. What do these 2 have in common? Was that 16, right? We found the greatest common factor in each of those categories. And then if you do it successfully, then it factors it for you, right? And then so from here, now we should be able to see, oh, well, these guys are going to cancel. Let's get back to our original question, right? So that's why I was like, we had to write this one out. So it looks like the final result there is 5x plus 16. So that was a loaded question. It was really a factoring question, right? I was hoping it was going to be lighter, but it wasn't, right? So we had to roll with the punches. Okay, so let's see if 5x plus 16 works. Okay, 5x plus 16. Yoink. All right, come on. 5, come on. Yo, come on. Maybe it's this. Let's close this out. 5x, there we go, 5x plus 16. Okay. So I feel like there should be questions, but you know, I totally understand. Again, this is why we have tutors. This is why I try to make myself available so you guys can ask questions, get some practice, and I try to encourage collaboration. I think that's important as well. So between me, your classmates, tutors, the internet, you know, yourself, one of those sources, something has to click, right? if you're, something has to click. Hopefully, right? Anywho, let's go to question number 8. Let me see. So that's what, 4, 5, 6, 7, 8. Okay. Determine if the function is even, odd, or neither. Okay, I think we should write this one out as well. I am going to do the poll. So let's relaunch that. So it wouldn't hurt if you wanted to like screenshot this. I'm going to screenshot it because I feel like we should write this one out for instructional purposes. Right there. This comes from section 1.4, question 27. Okay. That's all right. That's okay. I know you're going to do that. All right. So the question here is this function even, odd, or neither? I think that's large enough. Okay. Okay. So we're going to basically repeat the steps we did before and again interpret the results, right? So just a quick recap. So what we did before, we replaced each x with negative x. We simplify and interpret the results. Before we do that, let me give this summary on the definition of even, odd, and neither. So for instance, a function is even whenever we evaluate f of negative x, it gives us back the original. Okay. A property of even functions, they have y-axis symmetry. Okay. Whenever we have x comma y, we also have negative x comma y, right? So it's symmetrical about the y-axis. That's an even function. For an odd function, the definition of an odd function, when we evaluate f of negative x, we get a negative times the original. Okay. An odd function is going to have origin symmetry. Whenever we have x comma y, we also have negative x comma negative y. Okay. So I feel like that's a decent synopsis of the definitions of an even function versus an odd function. Okay. So then to test this algebraically, again, first we're going to replace each x with a blank set of parentheses. So we got f of x equals x to the power of 5 plus x to the power of 3. And then again, we're replacing each x with negative x in this case. Okay. So then with each of these terms, right? With each of these terms, we have a negative number raised to an odd power. Okay. So then it's going to be like negative x to the 5th minus x to the 3rd. Is this the original? This is not the original. If we factor out a negative, can we get to a negative times the original? Let me see. If we factor out a negative, we're going to have x to the 5th plus x to the 3rd, like this, right? So notice we started with f of negative x, and we finished with the negative times f of x, right? I think that's the definition. I'm going to go ahead. So hopefully you had an opportunity to submit your results. Okay, I'm going to close the poll. Okay, so I think we started with f of negative x. We finished with the negative times f of x. So that's the definition of a function being odd. Right over to the left. Okay, so that one should be B. All right. So let's see if we got that correct. Come on. All right, check. Okay. All right, so Okay. I don't know if that counts, but that's it'll be okay. All right. Okay. Let's do another question. I worked this same set with my students earlier, and it just feels like all the questions are totally different. Or a lot of them, or most of them. 18. Did we do 18 already? 3, 2, 3, 3, 2, 1, 0, 19, 18. So we'll do 19. Okay. So given this function, we're asked to construct and simplify the difference quotient. Okay. So another difference quotient, but this one, let me give a little bit of context here. So I know when we introduce average rate of change, and then I know I made a statement like average rate of change is essentially the slope between 2 points, right? And so difference quotient is a similar thing, right? We're going to be able to generate 2 points. And so the idea, to just kind of give it a little bit of context, is where, we have we have some x value, we have a curve, some function, and we're kind of concerned about like one x value. And then we want to see, like, given a second x value, and we consider the slope between those 2 points. As that second x value gets closer and closer and closer to the first x value, what's happening to our slope is getting closer and closer and closer to what number, right? And so that notion, that idea, is actually a concept in calculus called the derivative. The derivative is the slope of a tangent line at a point. For our purposes, we're looking at the slope of a secant line, right? A secant line is going to cross a curve at more than 1 point. A tangent line is going to cross a curve at 1 point, but it's going to graze the curve. It's not going to cut it hard. It's going to graze the curve, right? So again, for our purposes, we're just going to use algebra to simplify difference quotient. And again, the difference quotient is like we're observing how, as that second point gets closer and closer to the first point, how is our slope created by those 2 points? How is the slope changing? And so in the example that we had in the last question, the difference quotient was described where we had x, like f of x versus f of a. So f of a was like that second point that's moving closer to the first. Where this one is, you still have your x, like your point in question, but the second point is described as like some small change, h, right? So that's the denominator. So h is just like some small change on the x-axis. So as that small change gets smaller and smaller and smaller, or gets closer and closer to 0, now we're developing an approximation for our slope of a tangent line at a point, right? If we try to just brute force, graph a tangent line at a point, there's a lot of wiggle room in there. So it's kind of hard to get the exact graph, the exact tangent line, when you're graphing it manually. So what this does, it serves as an approximation, like the best approximation we can do for the slope of a tangent line at a point. Again, you don't really need to know all of that backstory for our purposes. You just need to know, like, be able to simplify these expressions using algebra, right? You don't need to know the backstory on that second point getting closer to the first point, which is the same as that small change in x getting smaller and smaller and smaller. You don't need to know all that. For your purposes, you just need to know how to like simplify these expressions using algebra, right? So let's get a copy of this guy. Let's get a copy. I'm glad we took some time to kind of give a little bit of backstory. You should have discovered that in my recordings. I'm pretty sure I gave some explanation there in my recordings. Okay, we want to simplify this difference quotient. Okay, I'm going to do like that. Come on, go. Okay, you move too slow. Okay, cool. Yeah, man. I always struggle in this like Wednesday class. Like my brain, my psyche be automatically in like weekend mode, and like I'm just trying to like be professional on some level, but in my mind, I'm like, okay, I'm gonna get them off. I'm gonna, do this attendance real quick, and then I know I got other stuff I need to do, but then I'm just thinking about like all the stuff, I'm finish this show, or I'm gonna go do a workout, or go running, or that's just like where my mind is. It's like, because this is my weekend, by the way. Like I have you guys, and then I meet with another group after you all, and then I'm off to the races. All right, it's ripping and running, whatever it is I want to do or need to do or whatever. But I was in your guys' shoes. I remember being a student, and yeah, it was. I don't. I mean, it was fun, but I'm good. I like being an adult. I get to say over like, okay, I control as much of my stuff as possible. If I'm not feeling the schedule, I just won't do it. Like I'll figure something else out. You know. Um, but I mean, I had good times. I ain't gonna lie. Like I was in Costa Rica for a month when I was a student at Morehouse. That was a lot of fun. It was a lot of fun. I had a lot of fun. I mean, just that experience is what you make it. But anywho, all right. Oh, we got like this might have to be the last one. Okay, so for given this function, we're asked to simplify the difference quotient. Okay, so for this difference quotient, we want to break it. We want to break it into multiple parts, right? So let's go ahead and isolate the f of x plus h. We'll do that one. We'll do it in purple, I guess. So we're going to isolate this f of x plus h, and we're just going to simplify that by itself first. So we're replacing each x first with a blank set of parentheses, and then x plus h goes into the blank parentheses. Then we want to expand this guy, combine like terms, and simplify as much as possible. So we're going to get x squared 2xh h squared minus 3, right? You can FOIL that, first outer inner last, combine like terms, eventually you'll get here, okay? So we got the f of x plus h, all right? So let's put all the pieces together, all right? If we were to say f of x plus h minus f of x over h, right? That's going to be the result we just found. So I think I'm just going to copy and paste. Minus f of x, right? So we need to distribute a negative. So you got to be careful about that. X squared plus 3. Let me highlight that. All right, we distributed a negative. Uh-oh. Uh-oh. What is this? Oh. These people are getting on my nerves. Whatever. I mean, it's going to be okay. What is that? Plus 3. Okay. All over h, right? So now the hint here is you're on the right track. After you do your cancellations, as long as each term has an h, then more than likely you did it right. Right. So for instance, this negative 3 cancels the positive 3. This negative x squared cancels this positive x squared. Notice that the remaining terms in top all have h. Okay. So then from there, from the remaining terms, ooh, sorry, I totally get distracted. Darn it. Okay. So from the remaining terms, let's factor out h. We're going to be left with 2x plus h squared. Sorry, not squared. Plus h divided by h, right? So the whole point is so that these guys cancel. But that's only going to happen if each of our remaining terms have an h, essentially. Okay. So then the furthest we can take it is 2x plus h. Okay. So now for our purposes, it's a little bit extraneous. It's like a lot of extra work. In calculus, we can just look at the original and write the answer. Like we have a method for bypassing all that algebra and just jumping straight to the answer, essentially. But for our purposes, let's keep going. 2x plus 8. Let's see if that's correct. So we got 2x plus h. 2x plus h. Okay. All right, I think we're out of time. Are there any burning questions before we go our separate ways? Okay. Well, you guys think of your questions. I'm going to go ahead and make a copy of these notes available. I'd like to share. I missed my box method, but that's okay. This still works. So right there. Come on. Okay, right here. 24. Traditional. 1. Notes did it daily. Okay. So when this little window closes out, you'll receive a copy of anything that you saw me writing. Let me check the chat real quick. Chat looks okay. Q&A looks okay. I know. If there aren't any questions, we're going to go ahead and end the session here, and I will meet back. Let me see. We'll end the session here from one beautiful mind to another. Have a great weekend, gentlemen, and we'll meet back on Monday to just go over the next installment. All right, and I'm going to stay on the call because I meet with another class in about 15 minutes. So I'm here if you have questions or need anything. All right, gentlemen, take care, and I'll see you next time. I'm gonna suppress my audio. All right, gentlemen, I'll be right with you. I'm just trying to get my image to push. Or just get it confirmed with my little my setup here. Don't connect the audio. Join. Stay as a participant. Okay. All right, looks good. All right, gentlemen. So welcome. Let me see. No, sorry. It's no real announcements, right? So I think we finished exam one on Monday that was due this past Monday. So again, my goal is to get you guys grades updated by this upcoming Monday. With any assignment, if you have less than a 95%, you're always welcome to go back. I think the late penalty might be a little bit more. One of the students brought it to my attention. I'll change it to 5% if I can, but if I'm not able to, because of the timing, it might not let me. If I'm not able to change it, and most of the B is 10%. But yeah, if I can, then I will. If I can't, then I probably won't. So what we'll do today is go through as many of the corresponding homework questions for section 1.4. We'll go through as many of these questions together as we can, okay? As usual, if you have questions, feel free to either type it in the chat or the Q&A. You can also unmute yourself as well. I'm not using my microphone today. So we'll start off with question 7. Hope everyone is doing well. Determine algebraically whether the given function is even, odd, or neither. Okay, so let's take some notes with this one, and I'm gonna launch the poll. So maybe if you want to like screenshot this so you can know which one you might like to submit. I'm going to screenshot it as well so we can take some notes. Okay. Okay. So before we get into the details for this question, let me give like a quick review on the definitions of even, odd, and neither. Right. So what do we mean by an even function, right? What do we mean by an even function? Yo, come on. Right. The definition of a function being even is when we evaluate f of negative x, it takes us back to the original. Some properties of even function, they have y-axis symmetry. And then another property is whenever we have x comma y, we also have negative x comma y, right? So it's kind of like you get 2 for 1. Whenever you have a point on the right, you also have a point on the left. You can use the y-axis as an axis of symmetry. It's going to bisect it. Okay. So then that's the definition of a function being even. Then we have the definition of a function being odd. So when we evaluate f of negative x, it'll produce a negative times the original. Okay. An odd function has origin symmetry. And then whenever we have x comma y on our graph, we also have negative x comma negative y on the graph. Okay. So that's a decent like synopsis or review of what do we mean by a function being even versus a function being odd. So then how to do this, how to evaluate this algebraically, what we're going to do is replace each x with negative x simplify, and then see if we can identify one of these two definitions. Sorry. Right? So first we're going to replace each x with a blank set of parentheses. Okay. And into the blank parentheses goes negative x. Okay. So then a negative number to an even power is going to be a positive. Positive times negative is going to be negative. Is this the original? This is indeed the original. So we started with g of negative x, and it took us back to the original, OG. So that's the definition of a function being even. Okay. Okay. So I'm going to end the poll. Okay. Oh, I think we're good. I think we're good. So let's go with the first one. Okay. Generate. Let's go to question 4. So here we're asked to find the intervals over which the given function is increasing, decreasing, or constant. I feel like the simplest way to go about this is to look at the graph, right? I think I'll use Desmos. Okay. I'm gonna break it off like this. Okay. I'm just gonna kind of type it as I see it. We can get it working. There it is. Okay. So then f of x equals negative 2x squared, negative 2x squared. Okay. So if this is our image, all right? So notice as we trace a graph from the left to the right, right? If we start from the far left and we start tracing the graph, it's increasing initially, right? So then over what portion of the domain is it increasing? As x moves from negative infinity up to 0, it should be increasing. So that's going to be C. We're going to go with C there. Okay. And then identify the intervals over which it's decreasing, right? So when x hits 0, then that's like a turning point. Now it's decreasing from then on. All right, so we're going to say the graph is decreasing as x goes from 0 to positive infinity. Yeah, it just got all of a sudden hit. Like this always happens. Like this is hour. Like I don't know why this hour is so hard for me. Identify the interval over which the function is constant. It's not constant anywhere. So we're gonna go with A. All right. So, and I think that's the first time that one has popped up all day. Yeah, I don't know how they are changing so much, but they are. Let's go to question 16. All right, average rate of change. Okay, so for the average rate of change, for our purposes, it's just the slope between 2 points, right? So we're just going to find the slope that's generated by the given information, the slope between the 2 points from the given information. Okay. So I am going to take some notes. Do I need to take notes? Actually, I think I'm going to try to do it here. I think we can do it here, all right? So the slope formula, so we'll take some notes here. So the slope between 2 points, I just know it as, I'm going to say my y sub 2 minus my y sub 1 over x sub 2 minus x sub 1. Okay. Let me see, xy. So what's my y2? Well, when x is 2, the output is 12 minus my y1 looks like a 0 over 2 minus 0. So that result looks like it's 6. 12 divided by 2 is 6. Okay. So all I did was find the slope between 2 points. If you want a copy of these, you can screenshot it. I'm going to remove my notes in 3, 2, 1. Okay. So hopefully if you wanted a copy, you've gotten a copy. Okay. All right. So again, all we did was find the slope between 2 points there. Okay. Let's go to question 14. Okay. Yes. So this is a piecewise function, right? Okay. So I'm excited about this one because with my earlier group, it was a little bit of like research on the spot, like because I wasn't sure how to type a piecewise function in Desmos, but we figured out a working. We did it 2 different ways, and I'm just going to try to present the way that was a little bit more functional, if I can remember the nuances. Now I think we had a set of curly brackets. We did our domain first, so we have x is strictly less than 0, and then I think we use a colon, and that applies to the function 4 plus x. Okay, that's a good omen. That looks good. And then we do comma. The next domain is x when x is greater than or equal to 0, colon, we do x squared. Okay, that looks good. And then for those endpoints, that first one needs to be an open circle. So what I'm going to do is click on the endpoint on the graph, if it'll let me. Okay. Another thing I can do is I'm going to plot points. So that looks like the ordered pair. When x is 0, the corresponding y is 4. I should be able to. It's not really letting me. That one is coming up. Why is this one not coming up? Well, that is strange. Okay. Can I do something here? No. All right, so we'll just plot the points. I think that first order pair was what, 0, 4? Okay. And that one needed to be an open circle. There it is. I don't understand why it's not letting me. Let me choose anything. Okay, there we go. Finally, I had to click like a million times, but we got it eventually. Okay, so we put an and we'll go ahead and match the color, I guess. So we'll do it in green. Okay, and the other one is the origin. So I think we can click on this one. That one looked like it was coming up. And then I'm gonna hit settings. We can get rid of that. Points. We'll do green is fine. And we want that one to be filled in. Okay. Okay. So this will be our image, right? So again, to get this to behave properly, you know, we had to do a little bit of digging. Initially, we kind of did it as 2 separate equations, but that technique was less functional. Like we couldn't. There were some features that we weren't able to use when we did it that way. So we dug a little bit more, and eventually we found something that suggested that we type it in like this. Okay. So the domain, right? So suppose this is our image, and we want to find the domain of this function. So again, in a graphical sense, the domain is the very left. to the very right. Okay, so what we can do is if we have to use our imagination, but if we were to take this image and smush this image onto the x-axis, what values of x would it touch? All right, what's the very left to the very right? So the far left is going to be negative infinity, and then the far right is going to be positive infinity. You might be tempted to say, oh, it's bounded as x is 3, but you have to understand that that's a parabola, right? That's the right-hand side of a parabola, and so it's just going to keep going off to the right. It's not bound or anything, right? There's no vertical asymptote, so it just keeps going to the right. It might take a while, but it does get to every x going to the right, okay? So long story short, in this instance, the domain would be all reals. Okay. Okay, so the x-intercepts. Let's see, where does it cross the x-axis? It looks like when x is -4 and when x is 0. So yeah, it's like it just got dark, like all of a sudden it just started raining hard. Yeah, I mean, but it's nice that we're at least like already kind of sheltered. You know, we don't have to like, I don't have to commute, you know, or be out in all of this. The wire intercept, right, where it crosses the y-axis. So with the left-hand part, it reaches the y-axis, but keep in mind there's an open circle there. So it actually doesn't touch the y-axis. It gets infinitesimally close, but it doesn't actually reach the y-axis, the left-hand part. The right-hand part starts at the origin, right? So that one does reach. So we only have one y-intercept, and that's going to be 0. If we had two y-intercepts, it would not be a function because we would have 2 points stacked on top of each other, and it would fail the vertical line test. So it would not be functional if we had two y-intercepts or more than one y-intercept. Okay, so then we're asked to choose the image, and so we generated our own, and the only one that's even close looks like it's A. Based on the graph, find the range. Okay. So then the range, if the domain is the very left to the very right, the domain is the very bottom to the very top. So if we took our image and smushed our image onto the y-axis, what values of y would it touch? All right. So how far down does the graph go? How far up does it go? It looks like it's going to be all reals. I feel like there should be questions, but I'm not going to press you guys. I treat you like adults. You're adults, right? So you know what you need or what you have questions on, and you have your own way of going about it. I'm really just here for support. Okay. And all I do on my end, I don't give grades. I just write down what you guys are doing. This person was here this day. They were here for this long. They submitted this assignment promptly. This one was late. They got this many out of this many correct. I'm just recording what you all are doing. But I'm not biased. Like I don't, if you've gotten it right, it doesn't matter how I feel about you. Not that I would feel any way about anybody in particular, but again, on my end, I'm not really doing anything. All I do is just make myself available, answer questions, try to encourage you all, and I just write down what you guys are doing and then crunch the numbers. But there's no bias on my end for any of this. All right. Okay, question 9. Let me see. That's 4, 5, 6, 7, 8, 9 is there. Okay. All right. So determine algebraically whether this equation is even, odd, or neither. Let me start the poll. Okay. Let's relaunch. Launch. Okay. Now let me think. I am going to make a choice. Okay, I see some people already submitting. I think it's this one just at first glance. I'm not saying that this is the right answer or not. I'm just at my first glance, this is what I feel like it is. I'm gonna leave the poll open. Let me get the copy and let's work through the algebra behind this. Okay, let's work through the algebra behind this. Hey, the news is on in the other room. They talk. I've heard them say tornado. Shit, do I need to bring? Like, can I put my car in the garage somewhere? I was like, man, I might need to. I feel like I need to get off. I was supposed to be going running some errands, but I might have to reschedule if we're talking about hail and tornadoes. I was like, wait a minute, it's definitely not a good idea to go out in anything like that. Okay, algebraically, right? Okay, so when we did this in the previous example, again, we replace each x with negative x, we simplify, and then we see that we get one of those two definitions, either for even or for odd functions, right? So we're going to do something similar here and see what happens. Okay. So first we're going to replace each x with a blank set of parentheses. We got x squared minus 2x over 5x to the power 4 plus 4. Okay. So then what we'd like to do is replace, we want to plug in a negative x into each blank parentheses. Okay. Now with that first term, we have a negative number raised to an even power. So that result is going to become positive. In that second term, double negative is positive divided by, okay, let's keep going. Even number of negatives is going to be positive, so that's going to be a positive 5x to the 4 plus 4, okay? Is this the original? X squared minus 2x? No, right? It's not the original. Can we factor out a negative to make it negative times the original? If we factor out a negative from the numerator, we're not going to get a negative times the original, all right? We're going to produce another negative that we don't need. So this is an example of something that should be, let me close the poll. Final answer is going once, going twice, 3 times the charm. Okay. Poll is closed. So I think this one is neither, right? Because we can't, when we did the initial analysis, we did not get back to the original. And we're not able to factor out a negative to get negative times the original. So this one is this should be neither. Weather alert. Yeah. Okay. So this is serious weather, like tropical storms. Tired metro. Tropical storm means that the tropical about 40 to 80, almost 80 miles per hour winds for the next couple of days. Heavy rain threats. Heavy rain. Not associated with Helen. Continue today into the night. Okay. I was curious if they were going to say anything about hail. Okay. But yeah, this should be an example of neither. Okay. Final check. Okay. I don't know. I mean, we can do it. Anywho, sorry. I'm thinking about when I get out with you guys. I was supposed to meet up. I keep hearing all this severe weather and it's dark out there. I mean, I can drive in that kind of weather, but if you don't have to, a lot of times you shouldn't. You know what I mean? Like if you don't have to get out in that chaos, because I'm a good driver, but there are a lot of drivers in the city that are not good drivers, right? And so all it takes is for you to miss just one of them, either in a rush, they don't know to slow down in severe weather, or just not being in it at all. You know, they still be driving like it's just normal conditions. They be like riding your tail. I'm like, yo, bro, if I have to stop, I know you ain't got no money to spare. Because if you do have money to spare, just give it to me. We can avoid the accident, all that trauma. You could just give your money to me right now. You see what I'm saying? Write a linear function that has indicated values and sketch the graph. Okay, so we want the equation of a line. Let's take some notes on this guy. All right, let's take some notes. Yeah, so that's, I'm like, we might need to reschedule. Because I was hyped to go out, but Not in this weather, not in crazy weather. That's not a good idea. Not in a city like Atlanta. They will F your shit up. He'll be messed up. And ain't gonna be no help, no compensation. Nothing from the car insurance ain't gonna help us. Ain't gonna be no help. So, unless you know how to do collision damage, it's just not worth it. All right, so a linear function, right? So let's do a quick recap. When working with lines, there are three equations that I feel like it's a good idea to have ready to go. Come on, that's fine. We have our slope formula, y2 minus y1 over x2 minus x1, okay? Our slope formula. And then we have our point slope formula. That's our y minus y1 equals m times x minus x1. And then we have our slope intercept. Y equals mx plus b. We'll use it as a reference. So we were given two pieces of information. We're given that when x is -1, the corresponding y is 2. And when x is 4, the corresponding y is 17. Okay. So we just rewrote the given information as ordered pairs. And then whenever I have ordered pairs like this, I like to just go ahead and label x1, y1, x2, y2. Okay. So let's start off by finding the slope. Okay. And if we plug in what's given, let's start off with so our y2 is 17 minus our y1 is 2. Our x2 is 4. Now it's minus a -1, right? So double negative becomes positive 1. Okay. And it looks like it's a 15 over 5, which is 3. So that's our slope. Now we could use point slope. I'm a fan of slope intercept. So I'm just a fan of y equals mx plus b. Okay. So our slope is 3. I'm going to choose the first point because the numbers are smaller and they're a little bit easier to work with. So our x is -1. We don't know b just yet. And the corresponding y is 2. So then ultimately b is going to be equal to, we add 3 to both sides, so that's 5. Okay, we got our slope. We got our y-intercept. So then if we put the information together, we're going to get, was it f of x? 3x plus 5. Okay. If this is correct, then we should be able to verify the initial conditions, right? So for instance, when x is -1, the result should be 2. So -1 times 3 is -3, plus 5 is indeed 2. That checks out. When x is 4, 4 times 3 is 12, plus 5 is indeed 17, right? So we got f of x equals 3x plus 5. So then here it looks like we just put 3x plus 5. We can get this working. 3x plus 5. Okay. Okay, so if we have 3x plus 5, we have a positive slope and a y-intercept of 5, right? So if we have a positive slope, it can't be what b, nor can it be d, because those both have negative slopes. And then I think C has the wrong y-intercept. It has a negative y-intercept where it should have a positive y-intercept. So by process of elimination, I'm going to go with A. Okay. We got just right at about 15 minutes real quick. Oops. Generate. Let's look at question 9. So we'll go to 10. It looks like we did 9 already. So the graph of a function is given to the right. Use the graph to find each of the following: the domain and the range. What's the domain? Right. So with this image, again, the domain is the very left to the very right. So if we were to take this image and smush it onto the x-axis, how far left does it go? The far left looks like it's -1. We're going to use a square bracket because it actually reaches -1. The far right looks like it's 9. We're also going to use a square bracket there because it actually reaches 9. The range is the very bottom to the very top. So the very bottom looks like a -1. The very top looks like it's a 2. Again, brackets for the same reason as the previous. So -1 to 2. Determine the x-intercepts. Where does it cross the x-axis? Oh, we might need to solve for that. Because looking at it, it looks like it crosses between 0 and 1. So to find it exact, we would need to find the equation of the line through those 2 points. So we're going to have to take some notes on this one. I'll just screenshot. Yeah, they're talking about like tornadoes and possible hail. Okay. And while we've been on this presentation or on this call, Morehouse sent something as well. They called, they emailed, and they text. I was like, man, acting like an ex. Okay, anywho. Okay. So if we want to find the x-intercept, what we can do, a game plan would be, let's find the equation of the line, that diagonal line, find the equation to those 2 points. And then once we have the equation, we can solve for our x-intercept. Okay. 333. So we are working with, we have this -1, comma -1. And then we have this 4, comma 2. So we're going to find the equation of the line through these 2 points. I like to label these x1, y1, x2, y2. Okay. So that means we're finding our slope, y2 minus y1 over x2 minus x1. Okay. So let's do like this. So our y2 is 2, our y1 is -1, our x2 is 4, x1 is -1. Okay. So double negative becomes positive in both cases. It's a 3, it's a 5. Okay, so we have our slope. Okay. I think I'm still going to use my y equals mx plus b. Okay, so our slope is 3 over 5. I'm going to use the second point just because it's no negatives, right? All right, so when x is 4, we don't know b. The corresponding y should be 2. So then b is going to equal, let me see, 10 over 2 minus 4 times 3 is 12. Sorry, that's not right. Let's back up. We want that to be over 5. Yeah, 5. So it's 10 over 5. Minus 12 over 5. To give us, looks like it's a negative 2 over 5. And we got our y-intercept. So, okay. So our claim is that y equals 3 over 5x minus 2 over 5. Okay, that's the equation of the line. Let's see. Let's verify our given points. When x is negative 1, negative 3 over 5 minus 2 over 5 is negative 5 over 5, which is negative 1. So that one checks out. Okay. And then when x is 4, 4 times 3 is going to be a 12 over 5 minus 2 over 5 is going to be 10 over 5, which is 2, right? So this linear equation works for those two pairs. So we can be confident that this is the equation of the line through those 2 points. So then finally, to bring it home, we want to find the x-intercept. To find the x-intercept, we set y to 0 and solve. I will work over here. So if we set y to 0, we're going to have 3 over 5x minus 2 over 5 equals 0. 3 over 5x equals 2 over 5. So we multiply both sides by the reciprocal. That's the same as dividing by 3 over 5, right? These cancel. So it looks like the x-intercept is going to be a positive 2 over 3. Yeah, no, I don't do drives in bad weather. What's the time? Okay, we only got like a little over 5 minutes. Okay, so we got an x-intercept of 2/3, right? So kind of roundabout, right? That one was not obvious. 2 over 3. Back up. Okay, I think that's good. Let me hit enter. Okay. Y-intercept, where it crosses the y-axis. So we can still use our formula because it's that same line. Let me highlight this guy. So if we want the y-intercept, we set x to 0, and we'll get a result of a negative 2 over 5. Okay, negative 2 over 5. Okay. Okay. Let me see. We still got a few more minutes. Okay, continue. Identify the intervals over which the function is increasing, decreasing, or constant. Okay, so as we trace this image from the left to the right, initially it's increasing as x goes from -1 to 4. So it's increasing as x goes from -1 to 4, right? So for our purposes, whenever we're submitting like a result for increasing, decreasing, or constant, we always use parentheses, okay? We always use parentheses. And the reason is like that forces us to always have 2 points to compare. Because if we use a square bracket and we're talking about the endpoint, then in one direction we're not going to have a point to compare it to, so we don't really talk about increasing, decreasing, or constant at a point. Identify the intervals over which the function is decreasing. It's not decreasing anywhere. Okay. It's constant as x goes from 4 to 9. So the open interval from 4 to 9. Good. Ooh, that was a good stretch. Okay, so for even, odd, or neither, even means y-axis symmetry. Odd means origin symmetry. I don't think either of those are at play here, so I'm just going to submit neither. We got time for one, at most two more. Let's do at least one more. Generate. Ooh, question 20. It might be a long question. 3, 2, 1, 20. Okay. Difference quotient, right? Did we do one of these earlier? Let me check my notes. Mine's neither even and odd. Okay, so let's do this. This is a good one. Sure about you guys, so I'm just going to say it anyway. So for this section, when we introduced average rate of change, we made a statement that that's essentially just finding the slope between 2 points. So the difference quotient, what it is, you have 1 point with its corresponding y, and you have some other second x value, right? Let me back up. You have one x value with its corresponding y, and you have a second x value with its corresponding y. And so those two x values we can talk about a secant line passing through the ordered pairs generated by those two given x values. So then, with difference quotient, we're concerned with, okay, as that second point gets closer and closer and closer to the first point, what's happening to the slope of our secant line, right? So then in this form of difference quotient, h in the denominator, it just means some change of x, some small change of x, right? So in this context, we still have our first x value, and then the h is a small change. Well, we're concerned with, as that change gets smaller and smaller and smaller, as that change gets closer and closer and closer to zero, what happens to our slope of our secant line, right? We get a better and better approximation for the slope of a tangent line at a point, right? So for our purposes, for the difference quotient, we just need to know how to simplify it algebraically. But what I just described to you serves as a precursor of a major concept in calculus called the derivative, right? So it's essentially this is like the intro to that. I feel like calculus is a little bit easier than this, at least in this sense of finding the derivative, because we have shortcuts. We can just like given this answer, we can just look at it and put the final answer. But here we need to work the algebra. Now this one is a little bit funky because our f of x doesn't have an x in it, right? So when we go to evaluate x plus h, there's no x to substitute. So it's just going to be 6 minus 6 divided by h, right? This one we kind of got off a little bit easy. So 6 minus 6 is going to be 0. And the only reason this one is light because there's no x to substitute. If you think about it, this graph is just going to be a flat horizontal line. So if you choose any 2 points, there's the slope between any 2 points is just going to be 0, right? I was kind of hoping one more we could work out the difference quotient. But that actually brings us to time. Okay, are there any burning questions? So hopefully if you have questions, you can get them out while I go ahead and make a couple one-on-one. Stop catching. Okay. Oh, box, come on. Here. 24. Traditional. Let me check the chat real quick. Chat looks good. Q&A looks good. Notes, updated daily. So when this little window clears, you'll be able to obtain a copy of any notes that you saw me writing. You can also, so my sessions today were all live streamed on my YouTube. You can go on there and watch the sessions from my 2 o'clock and my 9 a.m. Even though they went through the same section, a lot of the questions were different. So each group had nearly a unique experience. Some things are repeated, but it's not a bad idea to go and see what questions we worked on with them as well. You can also access their notes in the same way you access our notes, okay? So again, I'll be updating the grades over the weekend, and I can't think of anything else. So if there are any other burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen. And we're going to meet back on Monday, same time, same place, to go over the next installment. All right, guys, take care.
Thank you.
Okay.